Okay. Well, like I said, the last time, this is going to be a tough act to follow. I was really trying to find out stuff that we could see, and as you know, I make my emphasis sort of visual, binoculars, telescopes if you got them, but of course I'm writing for the paper as well. And most people only have binoculars, so that's sort of my focus. And of course, this always seems to wind up being 2 weeks out of sync with what I write for the papers, so I get to do it twice a month. So Charles Ennis showed me a really cool feature of stellarium where you can calculate the ephemeris of planets in our solar system and plot them in the sky, which I had not stumbled over. So we get to see that. The picture that I'll include was in my submission to the Coast Reporter. It's a screenshot from Stellarium, and they printed it in the top corner, about 1.25 inches square. So, oops. It's kind of interesting, especially if you have kids or you know of kids. You can do the little flip chart approach if the kids go out and mark, where they, of course, nowadays they do it with cell phone, which just proves I'm a dinosaur and they're smarter. You can actually see it move from night to night, especially against background stars. In November, just before the end of this appropriate period, we have a full moon and a lunar eclipse total, starting just after midnight. And in case you didn't see the moon occult Uranus on the 11th, and I didn't either, you get to see a close approach with the moon as it comes out of this lunar eclipse on the night of the 8th of November, and then a few other things. So this shows what Mars is doing from the start of October 2022 right through March 2023. And this screenshot shows the position of Mars as of tonight. And what's cool is you've got some significant asterisms and bright stars to place it against. Betelgeuse, Aldebaran, and Mars are all pinkish, reddish, whatever. And you'll be able to watch Mars move. And the weirdness in there, it goes left, then it goes right, and then it goes left again. That isn't just due to Mars's motion, it's due to ours, because we're overtaking it, and hence it goes retrograde as we pass it. Last month I showed Saturn, Jupiter, and Mars. It's more distinct the closer the planet is. Personally, I get a real kick out of it. However, it's one of the virtues of learning as much as you can about stellaria. So at 5 o'clock each morning, this is what it looks like due south. And you'll be able to watch Mars follow that little path through the sky. Now it keeps getting brighter right up to opposition. 6 months, I believe, Bruce. So there you go. Once it starts heading back again, it just keeps going east. And we're going east, and then eventually we go around the sun, and then it shows up west of the sun. Now, I like putting the date and time window in here because it helps people remember when you're looking. This is a stellarium screenshot again. So this is November 8th, 1:51 in the morning. 1 minute, 51 seconds, not 1 hour. So right after midnight, and just to put it in perspective, you can see down in the lower left, here's Rigel and Betelgeuse and Orion. So there's Mars, here's Jupiter, and the moon right smack in the middle of the two, about 55 degrees up, due south. And this is the start when it's moving this way, up and left, even though the stars are rotating that way. So it will have touched the edge of the penumbra, the partial shadow, at 1 minute after midnight. It keeps moving and touches the umbra, the total shadow that you can see right here. That's the dark area that it's entering. That happens at 1 hour, 9 minutes in the morning. And this little screenshot from 8 minutes later shows the moon moving in that direction up to about 10 o'clock into the umbra itself. And as it does so, more and more of it winds up not seeing any sunlight except what gets refracted around Earth's atmosphere. And from immersion in the umbra to emergence or immersion, that's about 1 hour and 25 minutes. Now, the color of the moon, it's surprisingly hard to find it if you don't know exactly where to look, because it's just so pale, most people don't see it. Now, it can be bright enough that it's a pink or a gray, whatever. All depends on the weather on Earth, how much light gets through our atmosphere. Just to light it up, you can see right here on the lower left, lower right corner, that's Mare Crisium. It's always on the west side. And that goes down first. And it's heading relative to the stars opposite from Mare Crisium, but it looks like the moon is moving with the stars this way. So anyway, that is during the total portion. And then it starts to move out. Now this shot would be at 4:39:41 in the morning. Now I've never seen this Uranus. I have never, to my knowledge, caught it in my telescope or binoculars, because I found that my setting circles and my visual skills weren't good enough to star hop. It moves, so you can't learn the pattern of where it should be. Doesn't move very fast, but it does move. And in 40 years of playing around with a telescope, I've never actually looked at it as far as I know. I might have a shot if I can stay awake until 4:30 or 5 o'clock in the morning. Right now, the moon, which of course by definition is full, is going to be extremely bright. And if you need binoculars to see Uranus, if you look at the moon, you'll blow your night vision for the next 20 minutes. So it won't be easy. You've got the haystack of the moon and this little teeny needle at about magnitude 5.7. I don't know if I'm going to be able to see it or not, but I'm going to try. Yes,
So why wouldn't you look for it when it's fully eclipsed? What would that be?
you can. It's just that if you're using a telescope, you can get there. Mine doesn't do it very accurately or very well. And I have a lot of trouble handling this stupid thing now because I'm not young, fit, and willing to hurt myself anymore.
I guess my question is there a particular reason why you're waiting until the sun is emerged from the eclipse to look at
it? I may try it with binoculars while it's still in umbra. Okay. If I zoomed this out and figured, okay, I'll go 5 moon widths up there, and if I can see something that's pale blue, that's it. I may try that, but I'm not trying to cover everything in 20 slides. Yeah, Bill.
Can you repeat Bruce's question?
Oh, yes. Sorry. Bruce's question was, why would I wait until the moon is coming out of shadow to look for Uranus? And that's a perfectly valid question. If I thought I could find it while it was still, by knowing where the moon is, figuring, okay, it should be 3 or 4 moon diameters away. Yeah, that makes sense. I might try that. If I get lucky, I'll let you know. Yes, Danny.
One little trick, if you've got Sky Portal or any of those on your phone.
I had Skyview Light, I think.
When I was looking for Mercury one time, easiest way, I just took this out, put it up, I found this on here, so I knew exactly where to look and then my telescope without, because this gave me a real exact point.
Well,
using the app on the phone, so that really helps now with that modern technology. It'll pinpoint for you. And it'll be very close.
yes, I'm sure it will. And, me and T-Rex have trouble using things with our tiny little hands. It's a very good point. Okay, that's enough. Whoops. Come on. Other things. I have seen and I believe it's pronounced zodiacal. It should be. If it isn't, it should be. Which is the reflected light from the dust in the solar system in the east before sunrise, because the ecliptic points up away, not just parallel with the equator projection, but up. So it's easier to see. I've seen it several times when I've been in Maui. But then you've got a dark sky over there and you're closer to the equator, so it's tilted more and you can see it. You could actually say, I could see where the Milky Way was, and this thing was at about a 30-degree angle to it. And I thought, that's the light. That's what it is. And it was really obvious. We might have a shot. Problem is, we've got Vancouver in the way, and the sky go from that is probably going to kill it, but it's worth a try. And we have a new moon, October 25th, and perigee 4 days later. I suspect the tides will be a little higher. Last December and January, if you remember, they were really high. And the inevitable letters to the editor about climate change, when they were the same height in December as they were in January, only in January we had a 30-mile-an-hour west wind blowing meter high waves onto Davis Bay, and that's what put all the logs up onto the beach. And it's not climate change, it's weather. However, Jupiter's just past opposition. It's near perihelion, so it really is big and bright. If you like looking at the moons, you'll never see them as well as you do now. Venus is invisible because it's behind the sun. And to do the same sneak peek, December 7th, that's what you'll be able to see as soon as the moon crosses in front of Mars. That is, I believe, 1 day away from Mars's closest approach to us. So serendipity. And that's about all I have. Are there any questions? Apparently not. Okay, thank you very much.
What time the Mars event is?
Well, this screenshot is showing 7:54 p.m. on December the 7th, and that's local time. I hope it's correcting for daylight saving. I spent an hour or two going through the observer's handbook, trying to calculate all the, because they give everything in universal time. And
They're all around boats, I know.
And it was sort of, wait a minute. That's not right. And then I realized we go off daylight saving time November 6th. And that's why all the stuff before I was out by an hour, because I was subtracting 7, or afterwards, sorry, subtracting 7 hours instead of 8. So, yeah. Anyway, that's, yes. There's lots of it to go around. Okay, thank you.